When I joined the task force, I did it because I read it on the mailing list of the CLARE network, and it was early spring, and it was Italy. So we've been, of course, the first country to be hit that hard in Europe. So I think I joined it out of the urge to help and do something, which was, I think, a common sentiment in Italy. I'm Davide Bacciu. I'm an associate professor at the Computer Science Department at the University of Pisa. And over the last 15 years, I've been doing research in machine learning, mostly at the crossroads between neural networks and probabilistic models. And I'm as well the secretary of the Italian Association for Artificial Intelligence and a member of the Italian office of CLARE. The topic that I've been leading is called Bioinformatics, and we deal with all the sort of data that is genomic data, so data about the DNA, RNA, both of the virus and of the human host, with the proteomics information, so the proteins that make up the virus and the proteins that are attacked by the virus in the human body, as well as molecular data, so basically drugs or the therapies that we're using to try to cure the diseases induced by the virus. And it's a fairly multidisciplinary group involving some 40 people with very diverse backgrounds, because we are putting together people who have a machine learning background, people who come from our classical knowledge-based AI, network data science, as well as experts of life sciences. So we're talking about clinicians, eugenicists, and geneticists. The choice of AI techniques that we've been using in our task force have been mostly driven by one cause. That was basically the lack of data. So when we started this work, it was early 2020. So the information available about the virus was really little. The data about the virus was really little. So we focused on using AI techniques that can mix the little data available with prior knowledge that were available. Prior knowledge about biological processes, about how proteins interact with each other, about how certain drugs, known drugs, interact with certain proteins, in the hope that we could transfer this knowledge that we have consolidated across the years into something that can help us understand better the virus, or create predictive models about the progression of the disease, or anticipate the effect of some drugs on the disease, in the attempt, of course, of trying to repurpose, relocate drugs that are used for some other disease to cure the disease induced by virus. Well, one thing that I've learned, that I had to learn actually from this task force, has been that of how to organize a group of people who basically have never met, most of them, with a very diverse background in a situation in which we could never met. That was a very challenging aspect, which we solved through mutual interaction by creating processes to interact, organize our work, carve out our goals, what we would like to do. And that was very, very interesting from the perspective of learning new things, learning how to manage the complexity of what is research work in the end, but under extreme pressure and under technical and personal difficulties. And I think that's a valuable knowledge that we should consolidate, because hopefully this is going to be the last emergency we are facing in time, but we should, of course, hope for the best but come for the worst. Data availability has been a major challenge when we started this work, and still it's not that common to have access to data, but it's clearly better now. But the key challenge that we're still facing is not access to the data, it's access to human resources. Human resources meaning people who have the knowledge from the clinical side, from the biological side, because those people are and have been the whole year and this year again involved in fighting the virus. So finding time with them to help us, AI expert, understand the data, understand the answers of our model, interpret the data and interpret the results of the computational models that we're building. That is probably the major challenge that we're still facing. I believe the next steps now are to bring the research that we've been doing out of our computers, out of our labs, transferring the research that we've been doing to those that are supposed to be using them. For instance, we are building models that anticipate the effect of drugs on the disease. We would like to transform those models into tools that can be used by the clinicians to help prioritizing the research. So transforming what is research into something that can be called a tool for the experts.